No, today. The short, sweet version today. Tomorrow, because hopefully you guys will have a little bit of time to maybe even start homework in class, which would be kind of nice for you guys. Tomorrow, I can go over homework questions kind of like preemptively for the sophomores, if that makes sense. I won't necessarily take all the time to do all the grading, but any questions on odds come with them. That way, we can kind of hopefully make the whole homework process go a lot easier. So we have our graphing calculators out. My pen is totally missing. I found it. Don't worry, we're good. Thanks for the enthusiasm. Okay. You don't need to be graphing anything today. But before we totally start today, I do technically have another page that's right before. Woo-hoo-hoo-hoo. Might the unit circle come back a little bit this section? Yes. We're not going to review it today because you guys know how to access the unit circle. We might review it tomorrow just a little bit, but for right now, unit circle stuff might come up a little bit in this section, but the nice thing is not really in the rest of the chapter. So don't worry, it's not horrible, it's not bad. Okay, here we go. Long story short, slope of a line. Old school, slope of a line. Wouldn't we just do a nice little rise over run? Yeah. Which could be delta y over delta x, which could be y2 minus y1 all over x2 minus x1. But in order to do that, don't we need 2 points? Yes. Question, do you guys remember if it really matters what order you put the points in as long as they're going the same direction? Nope. Okay, so that could have been x1, y1, that could have been x1, y1. As long as we just have them attached so that they go the same direction with the subtraction, you'll be fine. With these different lines, you have a horizontal line, a vertical line, a positively sloped, and a negatively sloped. A couple things they want to show you in the book, and I wanted to show you as well because I pulled it out of there, are the slopes of these lines. So, for instance, the slope of this line is m equals 0, right? But what do you notice about the angle that they put? They're not writing m equals 0. What are they writing? Theta equals 0. So wait, theta? Who's theta? Huh. I thought 0 was down here. Maybe it's like a vector that can be moved anywhere. And the slope of 0 versus the slope of 45 degrees, 90. Maybe slopes could be, in a sense, spoken of as angles also. Maybe slopes aren't just rises over runs. Maybe there's more to them than that. Question, what would be the slope of this guy? 1. Careful. 1 is up 1 over 1. 90 degrees or pi over 2 is the angle. That's the angle of this one. Even though it's not over here on 90, this line does have a 90-degree angle or tilt. But what would this slope be? Do you remember? Undefined. Good. Remember? Slope of 0, we can ski it all day long. There's just no slope. Right? Slope of 90, death. So, remember? You always laugh over it, then you don't remember it. So anyway, m equals 0 is going to be the flat one that's cross-country skiing, but with no tilt. M is undefined, is vertical sheer cliff. Okay. Then you have an acute angle and an obtuse angle. My question to you would be, what would be the sign of the slope if the angle of, inclination, that's coming. If the angle of inclination is acute, what would be my slope sign? Is this uphill or downhill? Yeah, assuming that we move left to right, right? Which is how we move in math. Like the number line left to right. So yeah, this would be a positive slope. M is greater than 0, uphill. And then this, well, by default, right? What's this one? Less than 0. It's a negative slope. It's downhill. Okay, so the idea of this picture is to say, hey, the angles of inclination might have some relationship with the slopes. The angles of inclination might have some relationship with the slopes. And the relationship is right here. That the slope of a line can also be found by taking tangent. Why on earth would they take tangent?
I have no idea.
Huh. Can we go back to the unit circle real fast? I know you have a question. Hold on, Nick. The bottom one's tangent, right, guys? Okay, we have 0, 30, 45, 60, 90. Right? And it's 1, 2, 3, 3, 2, 1, all over 2 and square rooted, and there's the zeros and ones that we didn't talk about. Square root of 3 over 3, 1 square root of 3. Growing, that's 0, and that's undefined. Wait, 0 at 0 and undefined at 90. What did we just talk about being 0 at 0 and undefined at 90? The slopes. So the tangents are the slopes and the slopes are the tangents? Why else does that make sense besides the zeros and the undefines at 0 and pi over 2? What if I was to make a little triangle right here for this theta? If I can make a little right angle between any 2 points, doesn't really matter, make a line. Wouldn't the tangent of the theta be the opposite over the hypotenuse? And wouldn't the opposite be the delta y, the change in the y values? And wouldn't the adjacent be the delta x, or the change in the x values? So when we do delta y over delta x, we could also say opposite over adjacent. And who's OA? Tangent. So this theta we're going to call an angle of inclination. And you guys have seen angles talk about how steep something is anytime that you've driven on a grade. What do I mean by a grade? Does anybody know what a grade is? Yeah, it's like a hill. It's the ones that say, like, turn off your air conditioners and warn the truck drivers to be careful about their brakes, right? There's one going on up into Bakersfield. That's probably the closest, most obvious one. And it talks about a percentage grade, or it's talking about, in a sense, the angles of inclination, how steep it is. Overheat your engine, yeah. Yeah. How about the M? Although, worst comes to worst, overheat your engine, just get some cold water poured in. And hopefully it'll make it a little bit further. How about the M, though? Except the newfangled ones, you can't really do that as well. The older cars, you could. Oh, Nick, you had a question. Go ahead. Sorry, bud.
Why is the angle for the first one 0 and not 180?
Good question. You technically could make it 180. But for angles of inclination, think about there are infinitely many different ways of saying it. We could say it's 0. We could say it's 180. We could say on adding 360. We could say a lot of different things. We're going to keep the smaller value, and here's why. Think about this line. How I said that the angle of inclination is acute. If you were like practically measuring this angle, the acute